You've already discussed atomic structure in prior classes, but we need to go over that. And so, what we're going to do is we're going to start looking at what makes up an atom. And there's a few things that make up an atom: protons, and protons are stationed in the nucleus. So, if we have an atom, those protons would be in the center of the atom. If we look at neutrons, uh, they are also in the center of an atom. So, I throw in a neutron. And then the electrons are actually in an electron cloud around the outside of the atom. And so if we just kind of change what we're looking at here, the electrons are going to kind of be out on the outside. If you look at this model over on this side, we see the electrons would be these guys, where the protons and neutrons would be in the center of the atom. Okay, so that's stuff that you should already know. Now, what we're going to do is look at who discovered those and what they discovered. So the first one we have to consider is the electron, and a gentleman by the name of J.J. Thomson had taken what's called a cathode ray tube. That's this glass lining, this kind of odd-shaped object, and evacuated all the gas out of the chamber, out of this tube. He hooked it up to a current source, and what he got was a what seemed to be a beam of light that kind of flew through this chamber. Well, once they put charged plates on either side, so positive up top, negative on the bottom, what they noticed is as it was going through there, it was bent. And so what they figured out is it was a beam of particles, and that beam of particles was negatively charged because it was attracted to the positive and it was repelled from the negative. And so what he came up with was these electrons, and we typically symbolize the electron with an E minus. Now, protons, on the other hand, were discovered by Ernest Rutherford. And Rutherford, what he did is he figured out that they were positively charged, they were located in the nucleus, and he also discovered the nucleus. And we'll talk about what an atomic number is. But the way that he did this, he came up with what's called an alpha source. Other scientists had discovered these alpha particles and figured out that the alpha particles were positively charged. And so what he was doing was he created this little alpha particle gun. Basically took a radioactive source, put it in a lead block, drilled a hole in it, and let the particles fly out the end. He smashed a piece of gold foil very thin. Most of the particles penetrated right straight through to the back. Well, what that indicated to Rutherford was that there's not much there, and that atoms are made of mostly empty space. And so if the majority of the alpha particles make it straight through, there's nothing there to stop them. But on occasion, he got some of these really hard deflections that came almost straight back at him. And what he determined there was that there was a kernel or some solid object in the center of the atom, and that solid object he basically is what we describe as the nucleus. He also noticed that some of these particles diverged at slight angles, and you can see it better down in this picture. And what he determined was that the alpha particles were positively charged, and that these particles were being deflected or pushed away by another positive charge. So he figured out two things. Number one, or three things: empty space, that there was a hard kernel in the core called the nucleus, and then that nucleus was positively charged, and so he said that we had protons. The next gentleman, James Chadwick, he actually figured out that the mass to charge ratio of the nucleus was not equivalent. And to explain that, he said that there must be some other matter in the nucleus. And that other matter he came up with was that it was a neutron, or a neutrally charged particle that was in the nucleus. And so James Chadwick, running a similar experiment to Rutherford, figured out that there was a nucleus, or a neutron. Now, mass number. What we've figured out is what we call an average or atomic mass unit. An atomic mass unit is 1/12 of a carbon-12 atom. And basically a carbon-12 atom, if we look at a carbon-12, there are 6 protons. So we got these 6 protons. 5, 6. Okay, so we got 6 protons. We got 6 neutrons. 1, 2, 3, 4, 5, and 6. And we have 6 electrons whipping around the outside. the thing that we figured out is the electrons don't have much mass. In fact, they're like 1,000 times smaller than the protons and the neutrons. But instead, what we figured out was that the mass, what we're going to do is take carbon as a standard, and we're going to make the mass of that atom be the sum of the protons and neutrons, since they make up most of the mass. So when you see me put carbon 12 here, that means that we have 12 particles, and really there are 6 protons, and so there's 6 protons plus 6 neutrons, which give us what's called the mass number, or 12. Okay, and that mass number, as we look at different particles, will give us how many neutrons there are, because the protons are defined by the, we missed it on the other page, but it's called the atomic number. So all elements are defined by their atomic number. Now, the isotopes. Isotopes are elements with the same number of protons. In fact, if we look at this, we have 3 protons, 3 protons, 3 protons, but we have varying number of neutrons. So 6 minus 3 gives us 3 neutrons, and I'm just going to put a little N0, meaning no charge. And this one would have 4 neutrons, and this one would have 5 neutrons. So it's the same element, but with differing masses because of the number of neutrons present. And so when we start looking at these different isotopes, we write symbols to represent them called nuclides, and these are the nuclides that are appearing on your screen here. And it's a symbolic representation of the element, the atomic number, Z, as we describe it, and the mass number, which is symbolized up here up top. So when we look at carbon-14, if we look at this particular isotope, what happens is we have 6 protons, indicated by that 6, and we have 8 neutrons. Okay, basically what we're going to do is we're going to take the mass number 14 minus the number of protons, and that comes up with our neutrons. The average atomic mass of elements is determined by what we said is that carbon-14 is our standard, but the fractional abundance of different amounts of substance. If we look at carbon-12 here, we figured out that 98.9% of all carbon is carbon-12. 1.1% is carbon-13, and less than 1% is carbon-14. So when you calculate the average atomic mass of something, you do what's called a weighted average. And so by this, what you do is you take the mass times the fractional abundance, and you take the sum of them all. And this little symbol, this little Greek letter sigma, means sum. So what we're going to do real quick, just to break this down, is I'm going to take 12 as its mass times 0.989, in other words, decimal form of the percentage, plus 13 times 0.011. And what we do is we multiply those together, and I think we come out to be something like 12.01. And this is going to be in atomic mass units. Okay, so that's the sum of all the isotopes. This will end this particular video, and we will continue on from here on the next video.